So in this video, we're going to see some features provided by Java in the math and random classes. Now the math class is actually part of the Java language, so it's in java.lang.math, so you don't actually have to import this class or this package, it's automatically there. So to start off with, there's some constants like pi, we see pi here, and there are some functions like absolute value. So we'll start off, we'll demonstrate those. And you can see you get pi when you print that constant, and if you call absolute value of 6, you get the result you expect. Now, I'm going to be doing this a lot where I write out the code and then call the code so that you can see what the result is. One thing you want to be careful of, though, when you do something like this is you want to make sure that whatever this is matches whatever this is, because if you say you're calling one function and you call something different or with different input, that can create a bug that's sometimes pretty difficult to figure out. Okay, so I'm just going to start copying in some code I've written before so that we can see what's going on with this package. So here we have exponents. So we have a power function that takes a number and raises it to a power. And here, in my view, I don't like remembering precedence rules and how things get converted from one type to another. So if I want a floating point result, I always use a floating point constant. So I can raise to a power, and then there's also an exponent function that returns e raised to whatever the parameter is. So when I run this, you can see here we have 2 to the 8th power. Here we have 27 to the 1/3 power, which is the cube root of 27, which is 3. Here we have 2 to the -2, which is 1/4, which is 0.25. E raised to the power of 1 is 2.718. And here's some other values I did as well, just so that you could see an example of that. And in addition to exponents, we also have logarithms. So if I just say math log, that actually takes the natural log. And I'll demonstrate that here where I take math exponent 1 would be e to the first. So when I take the log of that, then we should get 1. And then you can get the log base 10. There's a function for log base 10 as well, so we'll call that. And then finally, if you want to get something base 2, then you can just use the log base conversion rule where you take some log and then you divide by the log of whatever base you want to convert to. So here we want logs base 2, so we divide by 2. So let's run this. And there we go. So here, again, the natural log of e is 1, which is what we expect. The log base 10 of 1,000 is 3. And here you can see these are the appropriate results for log base 2. There's an overloaded min-max function that will work with either integers, such in these first two cases, or with floating point numbers, as in these next two. So when I run that, you can see it returns the appropriate min or max of those two numbers. So there's floor and ceiling functions. Just a reminder, floor is the highest integer not greater than the parameter, and ceiling is the opposite. It's the lowest integer higher than the value in the parameter. So when we run this, here the floor of these numbers is always going to be 9, and the ceiling of 9.1, 9.5, and 9.9 is 10 for all those values. So next, let's do some trig functions. So first off, all the trig functions take radians. So for my first angle, I'm going to do pi over 6. My second angle, I'm going to do pi over 2. And then for my third angle, I'm going to call the 2radians function with 45 as a parameter, which will give me the appropriate result in radians of 45 degrees, which would be pi over 4. So then I will calculate the sine, cosine, and tangent for each of those. And again, I'm going to check to make sure I'm calling with the right parameters everywhere, which I am. Good. And I will run that. And so I do have one bug. That's angle 3 there. So let me rerun this. And so you can see the results here are what you would expect. Now, one thing to be careful of, the cosine of pi over 2 is 0. And you'll notice this says 6.12, but notice this exponent is minus 17. That's a pretty small number. This is essentially 0. As long as you rounded this to less than 16 decimal points, it would be 0. So don't let that catch you off guard. That's not really a bug. This is essentially 0, even though you see 6.1 there. And then these other results are what you would expect. So for example, for 45 degrees, the sine and cosine are the same, and the tangent is 1. Again, just like before, you don't get 1.0, you get 0.9999, and so on. Okay, so there's some other math functions that you can take a look at. If you just type math and then dot in Eclipse, you can see the list of all the functions that are there. We didn't even cover probably even a fifth of these, but if you're ever looking for some sort of mathematical function, there's a very good chance that it's actually in here. In fact, we didn't even talk about rounding, but you can see that there's some round functions as well. Actually, that might be a good idea to do with the floor. So let's go ahead and add that here, since there are related functions. And instead of this, so let me change these first ones to round, just so the example's there. And looks like we have a bug. I'll delete that now. And so we can run this, and you will see when we round those values wherever we did that. So 9.1 rounds to 9, 9.5 and 9.9 both round to 10. And you'll notice those are integers, not floating point numbers. Okay, so the last thing we want to see in this example is generating random numbers. There is a way to generate random numbers with math.random, but I believe that there's other examples of that in other code examples. So in this example, I'm going to actually use the Java Lang random class, and we'll need to create a random object. I'll call it rand. Random is in Java util, so I will need to import that in order to get this to work. So the first function I'm going to do is nextInt. And so I'm going to, in a for loop, I'm going to call nextInt 10 times to give me 10 random numbers. And those random numbers are over the entire range of valid integer values. So I could use the min and max values that are in the integer class if I wanted to normalize these between some range, but there's actually an easier way to do that. So to get numbers, for example, up to 10, I can pass 10 as a parameter to nextInt, and that will use that as the range of the numbers. Now, this isn't the numbers from 1 to 10, though. It's the numbers from 0 to 9. So it's inclusive of 0, exclusive of whatever the parameter is. The simplest way to fix that is to add 1 to the result. I don't want to say 11 here, because now that gives me 0 to 10, inclusive, and that's 11 possible values. I only want 10, so I do this, and then I'll add 1 to get the numbers from 1 to 10 inclusive. So here is an interesting bug. Notice now all of these numbers, I have 21, 71, 0, 1. And all that's happening there is it's converting both of these to a string first. So I'm going to put it in parentheses, and that'll have it do the arithmetic before it does the string append. I didn't intend for that to happen, but it's a nice example. So here you see it's giving me the numbers, or giving me a set of numbers that are between 1 and 10 inclusive. So two more examples that I want to show you. Instead of integers, I can get doubles. And nextDouble will return a random value between 0 and 1. And so you can see those here. And of course, they're doubles, so they have a lot of decimal points on them. And then the last example, instead of double, I'll do nextBoolean. And when I print that out, it gives me a bunch of random Boolean values, either true or false. Essentially, it's like flipping a coin. So this will actually generate those numbers for you. Again, you might want to do some additional work on them to get numbers in the range that you want, but at the very least, these will generate random numbers. We're not really going to talk a lot about the theory of random numbers. There's a whole lot there behind that, but for our purposes, these functions will be sufficient.